that aim to make science more accessible and deepen student understanding. So we're really excited to host Shannon here today. And I'm super excited because she's going to be actually sharing one of the films or a part of one of the films with us here this afternoon.
Yeah.
So thank you.
Thanks so much, Brenda, for inviting me, and thanks for that introduction. Hello, everybody. I am excited to be here today on this Friday afternoon. Just to give you a quick overview of the next hour, as Brenda mentioned, you'll see one film from the Science Communication Lab. It's one that we've tested in an undergraduate classroom at NC State. Go, Carlos. I'll give you a preview of some of that data. There's also going to be 2 interactive breakout sessions today where we'll get to explore how short films can shape student science identity and their nature of science learning. Yes, exactly. Stephanie Matthews. I will mention her. I'll name drop her. Don't worry. And then, hopefully you'll leave here today with something that you could apply to your own teaching. So I'm going to go ahead and launch my presentation. Okay. Let's see. So can you guys see things okay? I don't see you at all. It's just so funny how I can't see you.
Great.
Yeah, we could see it.
Oh, here we go. Show video panel. There you are. It's just like, it's so weird, like talking into a void, All right. So as Brenda mentioned, I'm part of the Science Communication Lab, and we are a small education nonprofit based in Berkeley, California. Go Berkeley. And we like to use films and related activities to really try to broaden participation in science and to deepen an understanding of how science works. We are producers of 2 award-winning feature-length documentaries, Picture a Scientist and Human Nature. And we have a new feature coming out that actually Brenda has seen a preview of called Observer. And it's all about observation and the importance of observation in science and really just in the human experience. But we also make short films as well, which is one I'm going to show you today. And we've made over 24 short films on different biology and environmental science topics, and they're all free that you can find on our website. There we go. Now in the chat, I saw Attenborough, I saw HHMI, I saw SciShow, Crash Course. Those are all really great videos. We are a little bit different. For us, the goal isn't just about conveying scientific information. That's really important. But it's also about showing the people who do science and how science is done. And we do that by featuring scientists telling their own stories. And typically we have them tell their own stories in at least one of 2 ways. One, by sharing their personal histories, their identities, their paths to research, their motivations, as well as 2, their research narratives, which is really a behind the scenes view of a discovery, what was known at the time, what they did, the challenges they faced, etc. And so rather than, sorry, I can't see the chat. Let's see. Love the Messelson install video. That's another good one. So rather than bore you with, by telling you who we are, I'm going to show you through an example with this film, which is Decoding Ancestral Knowledge. And this film will seed the breakout sessions that we will have later on. So let me see, I practiced this before. Sorry, guys. Doesn't matter how much you practice. Sometimes it's still a little rough. Okay, here we go. Let's get this going.
Yay! Kahe kawai nui o kainae ka piko waina o kailua. For me, science is more than something that just asks questions. Science is a mechanism and a tool for me to malama aina, to care for my spaces. Science is how I learn about and connect to my spaces. I didn't become a scientist. I was born a scientist. My kupuna, my ancestors were natural scientists. So this area of Kauai Nui, Hawaii is fresh water, Nui is big. So this area is known for its extensive fresh water. These are some of our very, very sacred water sources. All of this water flows through and feeds all different types of agriculture. And then all behind me is what was the lokoi'a, the fish pond. You have to use a little bit of your imagination right now because it looks like greenery, it looks like vegetation. But in the 1800s, Kauai Nui was said to have the capacity to produce almost 500,000 pounds of fish per year. And it was managed so well from the mountain to the sea that you could literally eat the mud. But the flow of water has been disconnected. Part of that has to do with the fact that the Kailua community has been so developed recently. I felt really strongly that I needed to pursue science as a way to protect these spaces and restore them and bring them back to these spaces of productivity. I left Hawaii because I felt like I needed to learn things to bring back home.
We're currently diving to the deep, dark ocean, and it's very exciting. So we'll catch you on the surface.
I really wanted to use molecular techniques, genetics, to really understand who microbes are and what they're doing in the environment. After being away for almost a decade, that was when I really got rooted back to Hawaii, to my culture, with my language. What I try to do is to use contemporary techniques to decode the layers of meaning in some of our traditional knowledge. Hawaiians had an oral tradition. And so the only way to pass knowledge was through storytelling. So one of my favorite stories is at He'eia Fish Pond, this 800-year-old fish pond, and their kia'i, their steward protector, her name is Meheanu. And she's this fierce mo'ohine. She can take many different forms. We talk about her as a mo'o and a dragon, but she can also take the form of an eel. But she also takes the form of a woman. And they say that her job is to make sure that the fish in the fish pond are well taken care of. Are you mixing the waters? Are you making sure that predators are outside rather than inside? And if you, as stewards, do not do your job to take care of these fish, she has the capacity to hide them from you. They know Meheanu is in the pond when the hau, a canoe plant used for cordage, hibiscus-y like, turns yellow. And they say it turns yellow because she's relieving herself in the back of the pond. When I heard this story, I started thinking, yellow, urine? I wonder if this story has something to do with nitrogen cycling. Nitrogen is one of the most important nutrients in a fish pond, particularly ammonia, which is a form of inorganic nitrogen that's required for the growth of plants, the growth of algae, photosynthetic bacteria that fish like to eat. And so we had this hypothesis. what if when Mehanu's present, right, she pees in the pond, that might be associated with spikes in ammonia? So we set up this great experiment. We sampled over the course of the year, multiple times a week, with the stewards of the space. And every time we had blooms of puahau and the hau was yellow, we would see these spikes in ammonia. Some of those spikes were due to storm flushes from the uplands. So it's bringing down nutrients from the uplands down into the coast. At other times, you would see the pulse of nutrients come from the ocean side. Now, adding to that, we added this layer of microbiology. What we saw is that every time there was this spike in ammonia, we would then see these spikes in these photosynthetic populations, like Synechococcus. And these just happen to be some favored foods of the little baby pua'ama, the little tiny mullet that we're trying to grow. So you can imagine that, Mehanu's coming down, giving a buffet to all her little baby fish, making sure they're big and strong, and the microbial data shows just that. This story lasted 800 years, which means that there's probably still a lot more to decode. But it's really a beautiful lens to think about, what do we observe in our restoration practices moving forward? When there's too much nitrogen in the system, the hau is green. And when there's too little, the hau is green. But when you kind of hit this optimum zone of nitrogen, ammonia, you see all of the puahau blossoming and you have that yellowing. Maybe we also want to, like our ancestors did, plant them strategically to be used as biological indicators for the future. It feels like I've finally come full circle, but now is my deep investigation into this place to transform it back to what it once was, and collaborating with inspiring leaders with vision who lead with aloha. These are the communities that shaped me into being a Hawaiian scientist and a Hawaiian. My family, my ohana, my community, and my mud.
Okay, normally I would go through all the credits, but for time's sake, I will spare you that. Yeah, so you guys then get to play around in these breakout sessions and have a discussion about the film. Now, just to give you a little bit of context, so this first breakout session, I'm going to have you wear your learner hat, which essentially means forget for a moment that you're a teacher, and just approach this activity as a learner, like you are a student, and approach it as such. For your teacher hat, I think that's pretty self-explanatory. It's just basically be yourself. But we'll do those, the teacher hat breakouts later on. But for this activity in particular, I want you to have your learner hat on. And so I'm just going to give you a description of the instructions so you have clarity before we send you off into breakouts. So Brenda, if you could go ahead and start getting those together now, that'd be great. So we're going to split you randomly into groups of 4. And for once you're in a group, identify a role. So you can be a facilitator, a writer, a timekeeper, a reporter. The facilitator will lead the group in discussing 2 prompts, and you'll see the 2 prompts. It's on this one slide. So yeah, so you'll discuss those two prompts, and it's basically asking you to respond to the film. The writer is going to make a copy of the slide and write down your responses. And the timekeeper is going to, as the name suggests, keep time. So you'll want to spend 4 minutes roughly per prompt. So you'll get 8 minutes total in the breakouts. And then when you come back, the reporter, it's their responsibility to participate in the group share and to tell us what you guys discussed. So just to give you a preview, so these are the two prompts that you guys will be discussing in your breakouts. The first is, this video changed my ideas of what it means to be a scientist. Agree or disagree, explain. And then 2, from this video, what did you learn about how the process of science works? And so what I will do is I'm going to share those
Sorry, I opened the rooms. Where'd Shannon go? Uh-oh. Back to Shannon.
Awesome. So, so yeah, do we have any brave reporters that would like to share some of the discussions that you had in your groups around, how this film may have impacted your perceptions of scientists, or how it affected, how you may have learned something new about how the process of science worked? And feel free to just speak out or raise your hand. Either way works.
Happy to go. Hi, everybody. One of the things that, so I think our group talked about kind of 3 main points about question number 1. There was that kind of contrast between, do you become a scientist or are you born a scientist, that she really talked about, kind of becoming, like being born a scientist. We talked about the kind of contrast between, is it a profession that you learn, or is it like a natural instinct that you are born to, and that she kind of contextualized it as a natural instinct. And the third kind of contrast that we talked about is whether or not science is learning new facts and details of knowledge versus kind of discovering new things, and kind of the creativity that went into her conception of being a scientist.
That's great. That's lovely. I always think of, I didn't become a scientist, I was born a scientist. Like, that always resonates in my mind. Does anyone else want to add? Another reporter from another group?
Well, we were bad and didn't really assign people roles. So I can speak on behalf of room 4. And we really thought that it might be really inspirational to people who might come from sort of, I don't know, a background that we don't traditionally think of scientists from. I mean, I feel like the definition of a scientist is changing as we diversify and get more variety in the type of science representatives that we have out there in the world. But it might be really inspirational to help them to realize that, I mean, that they can be a scientist too, even though they're just sort of an everyday type of person.
That's great. Yeah, I do love how our definition is becoming more diverse. That's so important. Does anyone else want to add to that?
I think we hit on both of those points. We loved it that you were born a scientist, but not that you were becoming one. Maybe you were becoming better trained, but that training is different depending on what your viewpoint is. And that it's not just one type of, it's not the old white guy, Darwin with the beard, that does science. Everybody does science. And that people do science in different ways. That kind of leads into our next one. But that you're making observations and you're working with the information that you have. And so the elders, the traditional knowledge came from observations, and those people were doing a lot of science at the time as well. But it was just a little bit different than what you see now, potentially.
Yeah, that's beautiful. If there's no other comments, I can go ahead and continue on with the rest of my talk. But just in case, is there any other reporter that had something burning they want to add to the conversation? No. Okay. All right. So go back to. Okay. Okay, so let me find you guys again. You guys get lost every time. There you are. As I mentioned before, and as you saw in Decoding Ancestral Knowledge, we like to make films that feature scientists telling their own stories, where they share some of their personal histories as well as their research narratives. And this got us really interested in this question is, can films like these, films that have personal histories and research narratives of scientists, can they support content knowledge, science identity, and nature of science learning? Now, if you don't know any of those terms, don't worry, I'm going to define them in a second. So what do we know already about science identity? This is like a mini micro crash course. Science identity refers to how a person, sorry, let me move this out of the way, refers to how an individual perceives themselves as a science person and how they are recognized as a science person in social contexts. And there's research out there, particularly research through the Scientist Spotlight Initiative, if you're familiar with that, where they found that personal histories over time can support student science identities. And these formats are everything from written biographies to podcasts and TED Talks. So that's great, right? Here we have an intervention that can be effective in supporting student science identities. Now, what do we know about nature of science? Well, nature of science refers to what science is, how it works, its culture, and how society influences and reacts to its activities. Now, prior research has shown that written research narratives can also support students' nature of science learning over time. And now, why do we care? Why do we care about supporting science identity and strengthening nature of science learning? We care for inclusion. We care for trying to diversify a STEM workforce, because science identity is an important factor in the persistence of students in STEM, which is especially true for those from historically excluded groups. And then understanding nature of science results in a more holistic and accurate view of science that many predict is more accessible to a greater diversity of students. So really trying to support and strengthen these metrics in students is very important to us for inclusion. And so going back to our original research question, can our films with personal histories and research narratives not only support content knowledge, but can they also support science identity and nature of science learning? And so this is the study design that we set about in trying to address this research question. And here's Dr. Stephanie Matthews. We got to collaborate with her at North Carolina State. And what she did was she assigned her general microbiology students to watch Decoding Ancestral Knowledge for homework and then take a survey. Now, this survey had a mixture of quantitative and qualitative questions on content knowledge, science identity, and nature of science. For the sake of time, I'm not going to review the content knowledge data. I'm just going to summarize it at the end. I'm also not going to go through a whole other intervention we did in that classroom, where we also had the students watch another film called The CRISPR Apostle, and we collected data on that. You are welcome to learn more about that in our films if you're interested. Not in our film, in our publication if you're interested. And so here's the science identity data from Decoding Ancestral Knowledge. Do you guys recognize this prompt? This video changed my idea of what it means to be a scientist. Agree or disagree? Explain. That was exactly verbatim on the survey. 73% of the students agreed. And then in looking at their explanations, we did these qualitative analysis, and these were the 5 most prevalent themes that emerged. 1, scientists are passionate and personally connected to their work. 2, it countered the stereotype of the traditional scientist. 3, science can be inclusive and accessible to everyone. 4, scientists are influenced by culture and interdisciplinary approaches. And then 5, Indigenous people are scientists. That's my favorite one, actually, of all of them. I know we're not supposed to show bias, but that one is my favorite. And then for the next prompt that we asked around science identity, we asked specifically how this video impacted their own sense of identities as a scientist. So this video changed how I see myself as a scientist researcher. 65% agreed. And then these are the top 5 themes in their qualitative responses. 1, anyone can be a scientist, including me. 2, although my science identity is unchanged, I redefine people who do science. 3, I can leverage my passion and connection to the environment and my research. 4, I can integrate my personal identity and culture into science. And then 5, I can find motivation for science in everyday life. So that was the science identity data. And now I'm going to pivot and show you the nature of science data. No big surprise. Again, we asked the same question that you were asked in the breakouts. What did you learn about how the process of science works? And these are the top 5 themes. 1, I learned that science is a dynamic iterative process that evolves over time. 2, I learned how interdisciplinary approaches are integrated in science. 3, I learned how traditional knowledge is integrated into research of the natural world. 4, how cultural backgrounds and stories influence scientific inquiry. And then 5, how the scientific method can be applied. Okay, so this is just a summary of the data from the Decoding Ancestral Knowledge study. I'm summarizing the content knowledge, knowing that you haven't seen the data. You're just going to have to take my word for it. But large majority of the students demonstrated an understanding of concepts explored in the film. For example, the role microbes play in supporting ecosystems, and also how microbial diversity contributes to everyday life. And then with regards to science identity, the film expanded students' perspectives of scientists to include counter-stereotypical views, such as Indigenous people are scientists. It also bolstered science identities for a majority of the students, including those identifying as non-stereotypical. And then finally, it inspired students to leverage their passion, cultures, and identities in their research. And then for nature of science, the film expanded students' understanding of how science incorporates traditional knowledge, culture, and interdisciplinary approaches. And then it also provided an example for how science is dynamic and how hypotheses are formed and tested. And so the data that I showed you is from one educator in one classroom, and one way in which it was integrated into a classroom, right, where she had her students do these reflections. But there are many other ways in which you can integrate this film or a film like it to achieve specific learning outcomes. And these are just 2 examples from the K through 12 space. So here we have a middle school teacher that's using a Spanish translated version as a centerpiece to teach her newcomer students how to draw models. And then we also have a high school teacher that runs this intensive research program and has used the film to seed a nature of science lesson on how to formulate hypotheses. So if you're familiar with the hypothesis cubes lesson, that's exactly what she's done. And let me see if Christine is amazing. Yes, she is. She's actually one of our ambassadors this year. Okay, so on to our next breakout activity. So this is where I'll want you to put your teacher hat on, although I'm sure you already have it on now. And the same rules are going to apply as before. So you're going to be randomly split into groups of 4. So Brenda, if you could start getting that set up. And then again, try to assign roles if you can. If you don't, if you forget, that's okay. As long as you have a discussion. Facilitator, writer, timekeeper, reporter. We'll do 8 minutes, 4 minutes each, and then we'll come back and do a group share. And these are the prompts. Would you incorporate this video or one like it into one of your science courses? And then what discussions or activities would you scaffold around the film and why? So I'm gonna stop sharing and I'll let Brenda set up. And remember the shared slides, you already have them.
They're in the chat again, just in case
Great.
anyone missed it. So the link to the Google Slides is in the chat. So everyone can see that. And we're going to go back into the same rooms, I think.